Welcome to Predicting Grant Applications. Wrapping up. After completing this lesson, we should be able to extract useful information from the results of the grid search, including the average area under the ROC curve for each combination of parameters, the parameters of the best model, and the feature importances of the best model. Here are the results of the cross-validation and grid search we completed in the last lesson. One thing we may want to know is which set of parameters, that is to say, which parameter map, produced the best results. We decided to try two different values of max depth and two different values of num trees. This gave us 4 outcomes. Cross-validation was used to fit models using all 4 combinations of these two parameters. Average metrics returns the results of our evaluator for each of the 4 sets of parameters. Here we can see that all of our results look fairly similar, but the best results came from the second combination of parameters. This is the list of parameter maps again from the last lesson. We can see that the second combination, that is, the second parameter map, is the one with max depth equals 10 and num trees equals 100. Figuring out the best set of parameters by hand, just like we did, is workable when there are only a couple of parameters, but when there are more parameters or more values being tried, this exercise gets tedious pretty quickly. So here's a bit of Scala code that you can use to automate this. This method pairs each parameter map with its corresponding score. It finds the pair with the highest score and returns the parameter map from the winning pair. And we get a max depth of 10 and number of trees of 100. Another thing we'd like to do is to examine the winning random forest classification model. The best model is a method on cross-validator model that returns a pipeline model with the winning versions of the transformers and estimator in its pipeline. The last stage of this pipeline model is the random forest classifier we'd like to examine in more detail. We can print out the classification model for the best random forest derived from the pipeline model. Here we print the features, and the best random forest has 61,284 nodes. Let's have a look at the feature importances now. Here we can see that team size and PhDs don't seem to be very informative, and surprisingly, paper score doesn't seem to be that informative either. The first two and last two features are clearly useful. That's our value index, category index, and successes and failures. The big surprise here is that we would have thought that paper score would contribute more to the success of a grant. We may want to play with the way that we allocated this score to see if it changes anything. Also, we may want to have a look at how variable the feature importances are across other models, but that's for another lesson. Now summarising our results. When we used the default parameters, we had an area under the ROC curve of 0.909. That means that the probability that the model will predict a successful grant accurately is around 90%, which is pretty good. After a grid search, we got that up to 0.92. Running the grid search on a cluster proved to be a real time saver. And what we found out is that not all of our features proved very useful, so maybe you can try and get a better result. Having completed this lesson, we should be able to extract useful information from the grid search, including the average area under the ROC curve for each combination of parameters, the parameters of the best model, and the feature importances of the best model. Having completed this module about predicting grant applications, you should now be able to understand how to fit together the functions available in Spark's machine learning libraries to solve real problems, fit models in a fraction of the time using the Spark cluster,